Welcome everyone to another Integration Quest MuleSoft study group. Happy to have everybody here today. We almost got a full house. Glad to see everybody. We're going to have Ryan here today. He's going to be talking and presenting on streaming some binary data with the open source chunking connector. So we're happy to learn about this and see what's going on. Just a few things before he gets going. Everybody's been doing great. Just keep on saying that we appreciate everybody not saying something if your mom and dad told you not to say it. So everybody's been doing great there. We'll keep going. I was checking out the YouTube just a minute ago. No new subscribers this week, but happy to see the previous ones. So just keep on checking the links out, checking the archives. If this is your first time, follow these links that I have on screen and go over there, subscribe, leave a comment. I love replying back to people. I love hearing what is helping you. If any of these videos, just check out the old videos. I did recently get some feedback. So Diane was telling me that she knows somebody that just recently went and was checking out some of the archived videos. And he was saying he was amazed, like he was just blown away, the resource and wealth of information that's out there. So that's why we do this. We want to help people. We're happy to help people and happy to be doing what we're doing. So let us know if it helps you. Let us know what can help you in the future. That way we know what future study groups to do. So today, like I said, we have Ryan, and he's got a lot of experience and a lot of certificates and training. But like I always say, it's not just about that. It's the fact that he's willing to come and contribute and give back to the community and share that wealth of knowledge with us. And we really appreciate him doing that. So I'm going to stop talking so he can do that. Ryan, I'm going to turn this over to you. And as always, I'm going to keep an eye on the chat. So if anybody has any questions while we're rolling, drop them in the chat and I'll just throw my hand up and we'll ask as we go. Okay.
Sounds good. Sounds good to me, guys. I will. Hi, Francis came. Hi, Francis.
Hi, Francis. Glad to see you.
How are you? Cool. Let me get my screen ready to go and share it.
All right.
So I was solving a problem a buddy of mine had. And this is the timing of this whole binary streaming thing came up at an interesting time. I'm working on the 2026 version of the Integration Quest architecture courses, and we have upgraded from having just one architecture class or two. We've got a kind of a series, and they're shorter ones. So I was trying to figure out where streaming goes in our curriculum anyway, and kind of splitting it between kind of beginner and advanced. So this session is going to be both beginner. It's going to have some advanced stuff. We are going because okay, so this is a study group, not just a class. The thing with a study group is we learn together, and I've learned some things here. Streaming is an area where I learned new things this year, 2026. And I've been doing MuleSoft for all these years, and I had streaming wrong, and I was teaching people what the wrong thing is about streaming. So I'll try to get to what I had wrong, and I've now fixed in our curriculum, and obviously it's wrong in MuleSoft's curriculum, or it's vague in MuleSoft's curriculum. But the problem we're looking at is processing large data. Now, not all of it is binary, and my original introduction to how I learned this year was about binary data. But what I learned and what we're going to learn today is applies to all data, character data as well. And you guys are here at a time where I'm the one building the open source connector, and there's a roadmap that I'm going to need input on to see how much effort to spend to make it do more than I even had to do this first time around. So here's the problem. And the problem has to do with RAM, memory. Here. This is a RAM chip. See, I got a prop. You guys who's seen one of these? You guys seen one of these? And you held one of these in your hand? Anybody? No, maybe.
Oh yeah, plenty of time.
Yeah, I didn't do raising hands. Go ahead, Francis.
Apparently, the price has quadrupled in the past few months as well with AI.
I have a suspicion that was all Sam Altman's fault. OpenAI bought a whole bunch of committed to future purchases of RAM that puts a floor on demand. I mean, on demand, right? Which makes all the price. So yeah, RAM is super expensive now. It wasn't when I bought this one. I was getting price per gigabyte was great when I bought this one. Mule has to use RAM to process our data, right? And integrations have to process different amounts of data. And Mule is an extremely powerful data processing tool that I have been hearing nasty rumors for years and years and years that it's bad at large data, big data integrations, and it's bad at ETL. And I've always been skeptical of that because I know what the tool can do and I know how powerful the Mule runtime is. But it proves it when you actually try to do stuff, right? So I would think the performance of the Mule runtime, you can kind of look at it in two ways. There's the Ferrari sports car type of performance that it can do a whole lot of little things very well. And that's not what streams are about at all, right? That's Mule is really good at managing compute and handling a lot of concurrent requests. And that's what I think of in my mind as like the sports car performance of Mule. But the other side of it would be the truck performance of Mule. I don't know if any of you guys, who here is a sports car person? Because I am, like in real life. I rather have a sports car. Who here would like a big chunky truck? And you're that kind of a person. Put in the chat. I don't know if you're more of a fast little car person or more of if you had your dream car, which is your kind of car. Ronaldo likes big trucks, which is what streaming is. Yeah. So no, if I fast truck, get out of here, RJ. There's no such thing. What? They're not allowed trucks.
I've seen some. It happens.
A bicycle, Max. Oh, that's a win. Bicycle. So you're not going to carry a lot of wood home from Home Depot on your little bicycle, Max. Right? Francis, how do you get, like, if you want to go get a whole bunch of like sheetrock home, and what do you do in the UK?
We have to get it delivered by building distribution companies with lorries and truck and cranes and stuff.
That's expensive.
We don't have a lot of rock. I see it a lot in Ireland where people have trucks, but we don't have a lot of rock like brick walls or boundaries on people's houses.
Okay, sure. But I mean, even just to build a renovation inside your house, so homeowners don't just do that themselves?
Not really.
Oh, that explains it. Wow. Well, keeps industry working anyway. So here in America, especially in Oklahoma where I live, everybody does everything themselves. So like there's this Home Depot is this huge chain, and everybody themselves goes and buys all this wood and stuff and brings it to their house and changes their garage around. And that's very normal homeowner type of a thing. So they all have trucks. Anyway, that's the homeowner version. What Francis was talking about is more like what Mule is, like the professional trucks, right? Where you're going to carry tons of stuff from place to place. And this is where my first time meeting Ross Mason. Anybody who you guys know who that is, Ross Mason? Anybody know that name? No. So Ross Mason made Mule, guys. It's his thing. First, Mule was made by Ross. I met him. I think it was 2012. I met him at a Mule summit. Whitney knows him. I don't know him. I just met him. Right. But I don't know him. But anyway, I will tell you, Ross is at least 8 inches taller than me. So I go to shake his hand and I'm like, hello. Like, right. He's tall. But I asked him in 2012, is Mule going to become an ETL vendor? Because at the time, my company had Informatica and Mule, and they were competitors, not both owned by Salesforce. Neither one of them was owned by Salesforce back in 2012. They were both their own companies. And he straight told me, no, Mule's not for ETL in 2012. And then by 2014, the company changed their mind. So now it's 2026, 12 years later. And at least from a technology standpoint, MuleSoft is great at handling a lot of data. But how it does that matters to you and me, who are going to have to use it to handle a lot of data, right? So let me show you a lot of data. And the reason I had this slide up anyway is that there's some built-in good stuff in the Mule runtime that you all could already have been using all the way for years and years and years. And that's that MuleSoft has its own internal streaming, like premium level streaming stuff that it does in the payload, or it also could be in variables. So if your flow is carrying a Mule event and your Mule event has got a bunch of data that it needs to process, that data doesn't all have to be in RAM at the same time. RAM is expensive and RAM capacity is limited. If you go on Cloud Hub quiz question, if I get the 0.1 vCore, how much RAM am I working with? Anybody know? Anybody have a guess? You can look it up in the documentation. 480 gigabytes of RAM for the 488. Sorry, that's 1,000 times too much. 480 megabytes, megabytes of RAM, right? And there's plenty. Oh, go ahead. So
No, I was just laughing about the 400.
Yeah, gigabytes would be nice, wouldn't it? Yeah, for sure. I think this whole stick, this is 16 gigabytes, so that wouldn't work. So you can get a lot of CloudHub 0.1s on this, right? A bunch, which is the whole point. MuleSoft's the integration layer in between stuff. It doesn't need to be big and use a lot of resources, right? And it doesn't, right? So a stream, the idea of a stream is just you're going to page through the data. You don't want the event to carry all the data all at once. You want the event to carry little bits of the data and process it, right? So, so super simple coding example. I don't know if I still have it up in Anypoint Studio or not. I've got some things up here. This is my super advanced one. Let's just do a new flow here. And actually, let me comment out. I do a lot of this to try stuff in Mule. So the idea would be, let's make a Mule flow that just does a super basic stream, right? So I'm going to do basic, new config file, basic, right? And I'm going to have a little flow that runs like that. And it's going to run once so that we don't have, so yeah, about once ever. So once, right? That's not really once, but hey, that's not the point of this lesson, right? Okay, so I just want this flow to copy a file somewhere, maybe, right? So I decided to go get ready here. I have a bunch of stuff downloaded on my machine. I thought I'd use something big. So this is a file, the Ubuntu 24.04.3 desktop AMD 64 ISO. I just read it to you. Does anybody know what that is? Just trivia, it has nothing to do with Mule. What is that giant file? Anybody recognize that?
Well, of course, that's a CD image.
Yeah. Then you know what's on the image just by the file name?
What do you mean?
Somebody does. Who put that in the chat? Is that Whitney? A Linux distribution. Yeah. So that's the installer for Linux. Yeah. And it's binary and it's huge. So underneath it, I got some big files too. I got some videos of classes I taught, right? I've got the I've got a lot of videos in here. What else? I've got some installers of Anypoint Studio here. They're 2 gigabytes. So if I need to make an application process those, let's just start basic. Mule doesn't need any special customization. It's already great at that, right? So I can make the file connector go read a file, and this could be from local or on the network already, right? And we're going to go get that file. I'll go to my downloads. I'll go get the Linux distribution. Let me sort by size here. There we go. Go get the Linux distribution. Here's the desktop one. It's a little bigger. All the nice graphics. And it's going to be to read the ISO file, right? So very kind of straightforward flow, right? And there is a configuration when you read in Mule called the streaming strategy. That's just part of most Mule connectors, right? And this tells Mule what streaming implementation to use, because it implies Mule is going to use a streaming implementation. There's no option here to not use streaming, right? The fact that this is in the settings of the connector means it's definitely using streaming, and it's asking me what kind of stream I would like it to use. And I'm going to leave the default now, and we'll talk about consequences of that, right? So we're going to read an ISO file, and maybe we will want to, I don't know, upload it to an FTP server. Let me see if I still have it running. For this whole thing, this was a couple weeks ago, I decided to run an FTP server in Docker to test it. I do have it running. Let's see. So you can do this yourself. You just kind of have Docker running, and there's my FTP server. All right. So I'm I'm apparently running a little FTP server in RAM, and I can go and I just want to make sure I remember how to connect to it. Apparently, I just have it running localhost, test user, test pass. So now you could go run one in the cloud, but then the study group would take a long time because, well, it would it would have to upload over the internet, right? So here I go. I've got this FTP config for that FTP server, and I just want to make a little mule flow that uploads to that. So we're going to upload to ISO or Ubuntu 2.iso, right? I'm going to upload it to the server in some directory. And you see what it's uploading is the payload, right? So seems like that would be 6 gigabytes, but it's not going to be because we're using a stream, right? So we're going to write Ubuntu 2.iso. There we go. And run it. That's it. I'm trying to keep it simple. So I'm going to take a file from my local downloads folder, upload it to an FTP server. And I left all the default settings. And then we're going to see what it does. You know what I should have done? Should have put some logging in here because it's going to be pretty quiet. Do I have a here? I think I had the FTP server run in my temp folder. Let's see. Okay, I did. So it's at 2 gigabytes right now. That's not enough, right? So let me just do it. I'll do it like this. FTP data. So you can kind of see that the file size is growing, right? So Mule is uploading the file, and it's taken a while because it's a very big file, right? So I didn't have to do anything special. Mule is just able to stream without using all my RAM and having an out of memory error. So in order for you to believe that on my screen, I didn't show you how much. Are we getting the same size now? Yeah, so it's done uploading, right? Now, if I do that again, let's do that again, and let's put a logger here. A logger, we're going to put this and say we are starting the flow, right? We'll put another logger and says we are starting the upload, right? And then we'll put another logger here that says we are finishing, or flow is finished, right? So basically between every step of the flow, I want it to output a log, right? And then let me change this to write Ubuntu 3.iso. There we go. And I'll save it and it will redeploy. What's it doing? That's not what I expected it to log. Starting the flow, and then this says, oh, I missed that. Let's do it again. See, I put it in the display name. There. And then I'll change this to 4. There. Okay. Now my loggers are actually doing what we would want. I saw this giant, like this default log. I'm like, what happened? It's because I forgot to give it a message. So it should restart. And what's interesting is it's restarting now. And the upload, see that? The upload was halfway done, or about 3 gigabytes. So now we have restarted, and it says, starting the flow, starting upload. And now it's uploading, see? So it's able to load the data incrementally, even though it's past this step. So the read didn't use all my RAM. Look, here's my run configurations. So when I run this application, this is the streaming connector one, yeah. Does it say Well, I could just do it this way. I could do it this way. We want to see what the running Java process's RAM usage is because we hope it's not 6 gigabytes, right? So Docker's using a lot. Anypoint Studio and Java are using less than 2 gigabytes. So I think that's probably good enough evidence. We are not using 6 gigabytes of RAM. And the process works just fine, right? So basically with that, it's declarative configuration. I told Mule, please use streaming, and it was already using streaming. And I didn't set any special configurations, and it just kind of works, right? And that's because that's kind of what MuleSoft wants to do, is just handle basic uploads for you, and data streaming. Now, a lot of Mule flows don't. They have work to do. Maybe I need to transform it or something, right? And that's where this stream starts to be starts to need us to write. We need to be able to manipulate the stream in some way, maybe loop over it or something. So let me show you another little more advanced flow. Same thing, right? Flow's finished. Also, let me delete some of these files on my drive if I'm not careful. I'm just doing gigabytes and gigabytes and gigabytes. RM Ubuntu star .iso. There we go. Let's see, how am I doing on disk space? I still got hundreds. I guess I had a little. All right. So let's get rid of that and let's make another one that does something with it. All right. So let's see. Maybe I want to do yeah. I'll start with that. Maybe I'll just update the basic. No, I want to do two. I'll make a scheduler here. We're going to run once. And then we're going to download that same file, read that same file. Oh, this is downloads. And there's my desktop ISO. All right. So read Ubuntu desktop ISO, right? And now let's say I want to put it in two different places, right? So just like before, let me put that on. I'll put the logger in this time. And we'll say starting uploads. There we go. We're starting the uploads. And now we're going to do two things at once. Okay, so I'll take my little, or we'll do two things, and then after that, I'll do two things at once. So first, we will upload it to the FTP server like we just did, right? So upload to FTP, right? And we'll put that again at Ubuntu. Well, I guess I can just start at the beginning again since I deleted everything. Ubuntu 1, right? And then I want to also go write it to a different directory, right? Maybe I want to write the same file to two places, right? And I can do them in series or I can do them at the same time. So this will be /temp/archive/Ubuntu 1.iso, which is a lot of times when you're dealing with large stuff, you have to do that, right? You have to do more than one thing with it. Maybe archive it and process it, something like that. Or zip one, and I could do that. I could zip this one. That'll use RAM. All right. So I'm not going to run it yet. I'm just going to say out of the box, MuleSoft does this okay as well. And it doesn't fill up RAM. That's because what MuleSoft did to save us from ourselves is they made a way for the stream to buffer using the hard drive, right? So if I go to read under advanced, the type of stream out of the box is a repeatable file store stream. And that means MuleSoft's going to take the stream that we're downloading and buffer it to the disk so that every time we need to use it, it'll read from disk instead of RAM. And then we won't fill up our RAM and crash the server, right? So that's kind of nice. Out of the box, we won't get a crash, and this will also work. I'm not going to run it because that also works if I wanted to show if we do it at the same time. Process is reading their own copy. It's not a copy, it's a cursor of the same exact stream on the disk, right? So here's my upload. Here's my archive. So it's pretty, this is the nice things that MuleSoft thought of for us already. I can take the same file and do two different things with it and not crash my Mule server. I just want to appreciate the nice things we have, right? And we still haven't needed to chunk it, right? This is good. So far good. So far so good. Out of the box, this works fine. The other thing I can do, if I don't want to use my hard drive, is I can configure it to use an in-memory stream. And that means the stream has to stay in memory, and we can put a maximum size on the stream and raise an error in the application if the stream is too big for the amount of RAM we want to budget. Because, when you go download, you might not know day to day how big a file is going to be. It might be something you need to, if your use case is one where you want to use error handling instead of crash the server, that's searchable. Right? I could just put an on error continue here, and there is a mule error called stream maximum size exceeded, and then we can do whatever error handling we want there, right? So what to do if the data is too big for memory, right? So the documentation for all of this in the Mule website is pretty good, right? So if I go to docs.mulesoft.com, until runtime, there is a streaming. Is it under here? I think it's under here. No, it's not there. Where is it? Develop. Usually I don't end up having to. I'm just going to search for it. Streaming. There's two good pages that I want to be in the video, and I want everybody to. There it is. Found it. That's not it. That's why I didn't want to search. It's under here.
You see that question, Ryan? Maxim is asking, so if the writes would stay sequential, would it execute like read and buffer for each write task separately?
The buffer, so the question says, if the write is sequential, so there's an if there at the beginning of the question, and they won't stay sequential. Each one of the two stays sequential, but they have no connection to each other. So the top one is going to have a cursor, which is just like a pointer to the stream. The bottom one has its own cursor, and they both end up writing all the data in order from the same buffer without interfering with each other. Yeah, that's the design. And no matter what I pick for my streaming strategy, as long as there's two different repeatable streams, that's the case. They both are capable of keeping the two writes correct without missing any data, without getting it out of order, right? And share a single disk buffer for the file store stream. For in-memory stream, it's the same thing, but it's buffer instead of a buffer. So they'll both stay in order, yeah. That clarifies, yeah.
Yeah, maybe I'll ask my question again. So in this case, it's clear for me how it works when it's a scatter gather, when it's in parallel. I mean, if they were sequential without a scatter gather.
Same thing, yeah. They're just, whether they're sequential or not is completely unrelated to how they don't know if there is. Each one of the operations has a cursor, a pointer to the buffer, and it doesn't care what else is using the buffer.
Okay, so it would keep the kind of each chunk open, each chunk string open.
The one that reads first is going to download and write to the buffer. And this is what I learned this year. Nothing clears the buffer until everybody's done with it. And then the stream is closed, and then the buffer is disposed.
Oh, okay, that was my question. Thanks.
That's a good question, because I assumed for years that the buffer was dynamically cleaned up by whatever the last user was, and I found out this year it was not. So that was bad news. And stay tuned on that for the chunking connector, because I got mad and made it do that, basically. So let me put them back in parallel. So what Max was asking everybody, like, if these are both going, you would hope it doesn't need to put the whole ISO on disk, because they're both processing, but it does. It keeps the whole thing on disk until they're both done, and then finally cleans the whole thing up. So we're going to use a full 6 gigabytes of disk buffer. for this to run. Yeah. So this is, I want this in the, I'm putting this in the chat, and maybe we can put this in the comments of the YouTube video. This is this is the written version of what I was just showing you in the built-in Mule runtime. And we just covered repeatable streaming. So why would I ever want to use non-repeatable streaming? Well, usually I don't need it. Usually there's not a reason to use non-repeatable streaming unless asterisk, right? And here's why you might want to use non-repeatable streaming. So, where am I going? So okay, that disk buffer is always going to be filled up, right? It's got to keep the whole thing in it. If I want to read in pages, MuleSoft already has a way to do that too. If I want to process pages, and that's from the DataWeave language. So the DataWeave runtime has a streaming feature where it can read certain kinds of data in chunks and allow you to process chunks at the same time. So let me put that also at. So I can go and take, instead of the ISO, let's say it was a big JSON file or a CSV file. I'm not going to run one right now because I want to have time for the streaming connector, right? So let's say I had an example CSV, right? I could make the MIME type. I tell DataWeave that this data coming from the file is actually a CSV, and I would like to enable streaming reads. And what that would let me do is I could take, let's say, I could take pages at a time. I could make a little for each loop, right? And I could process 10,000 lines of the CSV file all together like this, right? And do something with them, call an API or whatever. If I want to page over the CSV input, I could do that. Let me do logger. Here we go. But I could call an API. I could make separate chunk files. So I could have like CSV page1.csv. I could have an output like that or turn it into JSON. So this process a page instead of the whole thing, right? And we often need to do that when we're doing large data processing, right? So this will allow you to read a page at a time. However, because of the Mule repeatable streaming infrastructure, all those pages are still going to get stored on disk, right? So this works great as long as you have enough disk. And guess what you don't have a lot of in CloudHub is disk, right? So let me show you the limits. And it depends on your runtime environment. But if you're using CloudHub, your limit on your disk is going to be what? This is a for example. You know, probably most MuleSoft customers are on CloudHub, but not all of them. So for the ones who are on CloudHub, they're stuck with 20 gigabytes of disk max. So guess how you can't process any data that's bigger than 20 gigabytes with repeatable streams on CloudHub. That affects everybody. Like even if you use all the good streaming stuff, this is your upper limit for what kind of data you can process on CloudHub, unless you use the non-repeatable stream. That's why we need non-repeatable stream. If I'm going to go for the super big stuff, which there's problems that are that big, right? If I want to process something giant, bigger than 20 gigabytes, I can't use the disk, right? It's not going to work. So I have to use a non-repeatable stream to process it. And now what that means is I can't do two things at the same time. I can't write it to FTP and write it to disk. I can, when I'm using a non-repeatable stream, I am stuck doing only one thing at the same time, right? So the limits on really large data in Mule are kind of specific. I have to use non-repeatable streams, and if I'm using a non-repeatable stream, I have to only do one thing with it, right? That's my limits. And for years, MuleSoft customers have lived with that and worked around it and gotten by, right? But what if I need to do something with binary data like the ISO, right? So here's what I did, right? I did something with that. Let's open this one up. What happened in January is a friend of mine in the MuleSoft community had an issue with he needed to process a large binary, and and it was not fitting on his runtime. Like, so how do we chunk it? So I got frustrated. I've been wanting this for a long time anyway, and I went and looked to see if I could make DataWeave do it. And turns out that part of DataWeave currently is not extensible to make, because what I really wanted to do, guys, and I wish we could do it, and Mariano, if you're watching, please, can we do this? But right now we can't do it, right? I really wanted to make my own streaming data format for octet stream. I wanted to just stream input like this and just give it a chunk, right? And I went to try to do it, and the extension for DataWeave formats doesn't give me a way to do streaming. It's not, MuleSoft hasn't yet made it extensible by customers in that way. So I'm stuck. So I couldn't go this route, but the Mule SDK is available. So I made a connector called the chunking connector. We published it on MuleSoft Forge, and it's in Maven Central, and this is it. So here, this is how you see it. It's Apache licensed, and all you got to do is add a Maven dependency. This, and to your project, and that's what I did in my example here. And then you can take any stream, and same thing I was doing here, but with binary data. Instead of 10,000 lines, you can do bytes, right? So let's see what I was doing here. Why was I doing CSV? I don't remember why I was doing CSV. Let me look and see. Big colors.csv. Seems like this is just an example. So, oh, I know what that was. That's when I was figuring out how to do it in Java. Here we go. So here's a flow that does it. Let me turn the other one that's off. Good. So I've got this flow. I'll run once. And this time I'm going to download a big file from FTP. I decided to use FTP as my, well, here, I'll do the one I just uploaded. There we go. I'll download a big file from FTP, and I use an operation from the chunking connector called read chunked. It's the only one there, which I give it a chunk size, and it has streaming strategies. File store, in memory, and non-repeatable are the same ones that MuleSoft has. And then I can loop over the chunks. And what comes out of that connector, there we go, is a kind of a complex object. I don't know what happened to my metadata here, but it's an object that looks like this. I'll just show you in the documentation for now. So when you read a chunk, you get an object back out that has the actual chunk, what the order of the chunk is, how far it is into the stream, how big it is, whether it's the first chunk and whether it's the last chunk, right? So you're going to get a stream of chunks one at a time. They're objects, right? And then you can process each chunk individually. And I'll show you what that kind of lets you do. So here I decided to use the file connector. So it's like downloading a file from FTP. I went the other way around. But on the first chunk, I decided to overwrite the file. And on all, so I used a choice router, right? And on all subsequent chunks, I appended to the file, right? So now that allows me to do something for every page coming out of the binary. So I'm downloading from FTP, processing pages, and I'm not saving all that data on my disk. So I can go arbitrarily large. I could process a terabyte in chunks this way, with a Cloud Hub, tiny little Cloud Hub worker, right? And write it to now I'm writing it to a file, but maybe I could upload it to another FTP server or S3 or something like that, right? And kind of the use case I was using as my UAT for this whole thing. Let's imagine I'm using S3. S3 has this really cool feature called upload part, right? So I can make a process. This is surprising. There we go. I can make a process where I create a multi-part upload before I start, right? And then each chunk, I upload a part, right? And so whatever, I'll do it like this, right? And then at the end of the whole process, I complete the multi-part upload, right? So I can start with binary data and upload it in chunks to S3 or FTP. I have the power to work with this binary data in smaller parts if I want. I can transform them first. It's completely up to me, right? So that's the purpose of the chunking connector, and why we did it is so we could have, so we could be able to process this data in smaller pieces. Now, this time I did a non-repeatable stream because I wanted to kind of just solve the basic problem. How do I process binary data in small parts on a Mule application? And I put these different streaming strategies in here because what if I want to do two things with the chunk, right? I have the same problem that we had before, right? And when I found out Mule saved the whole thing on disk, I didn't like that because this is designed for really big data. So I created another streaming strategy called sliding window, and I give it a max number of chunks for the window size, and now it'll only carry that many. And they're all in memory. All those chunks are in memory, but you can keep so in this case, I wanted to have two processes that write to different files, right, from the same input in chunks, and that's what this does. So if you wanted to make a new application that uses streaming yourself, let's just do it from scratch. So my chunking app, right? You have to have Mule 4.9 or above. I decided not to support 4.6. Sorry, right? And you just go to the POM XML, right? And go to the dependencies section, and you go to the setup screen on MuleSoft Forge. It'll give you a dependency. So you copy the dependency, and you put it in your POM file. There we go. And now, when you save that, you will see the chunking connector appear in your package explorer. And it doesn't look the same in ACB. It looks a little different in ACB. So close others, and now I have access to the read chunked in my code, and I can just build the application and deploy it. So this has been released about a couple of weeks ago, and I know my buddy Matthias is using it. I don't know who else is using it yet. It's brand new. So my next steps is I'm thinking about adding delimiter chunking, right? So you can't text in Mule right now. You can't chunk text plain. So if I just want to take the data coming in and break it up myself by delimiters, I'm thinking like for large flat files from legacy systems or something. So probably the next thing I'm thinking of adding is delimiter based chunking, but that hasn't been done yet. So right now it's just a fixed chunk size using just a number, right? So that we can do binary. So I went through kind of basic MuleSoft stuff, and then I went through not basic, but advanced MuleSoft streaming, and then what the purpose is of this chunking connector. The connector's on GitHub. You can do pull requests, and this website is also on GitHub. So MuleSoft Forge is just a place where we can do open source MuleSoft stuff together. And we have our own power to release to Maven Central, and we don't need to wait for MuleSoft to put stuff in Exchange. We can just kind of make our own stuff. And there's a couple of other connectors in here. JSON Logger will be in here soon. It's not in here yet. So that's the purpose of MuleSoft Forge. And I guess I can move on to questions about either streaming in general or the particular little edge case chunking connector that we have on MuleSoft Forge. Would it support resuming operations?
Yeah, I mean, if something breaks like halfway through reading the file, and then system crashes, and then you restart.
You'd have to do it. So with that, You could code that. You'd have to code it. Here's how I would do that. Right. So coming in. Right. I've got some giant thing. Maybe it's well, okay. If it's an HTTP post, yeah, we could do it. Wow, I was about to say we couldn't do it. I think we could do it. So let's say somebody's going to post a giant thing, because I tested this with a post and Postman. Postman, by the way, Postman is good at large posts. You can get a giant ISO and post it. So a giant thing gets posted here. There we go. And we want to read that and then loop over it. And then we want to resume if something fails. So actually that's super easy. Now that I think about it, it's not even. Let's make it harder. Let's start with the easy one though. Let's say we're going to take pages and post them somewhere, right? Very simple. So, post page somewhere, and that could fail. I guess we could just put that in an until successful, and then it'll keep trying this chunk until it works, and then we keep going with later chunks. So that's kind of the base case. I'm sure there's more complex resuming cases you could think of.
I think I was meaning some. Let's say you're reading a huge CSV file, like several gigabytes big, and then so you're halfway through processing it, process 4 or 5 gigabytes, and then things crash.
The whole thing crashes.
So at the next start of your Mule engine, you would like to kind of continue, right? So you would have to do some checkpoints.
A bit like how Patch is supposed to resume.
Yeah, kind of, yes.
Let's see if we can make it work. I think, okay, so let's say we're going to read giant thing, right? And we're going to read it chunked. I don't think I can avoid downloading again the next time around, unless the source connector supports a watermark. If I can tell FTP to start at a later byte, then that would work. But FTP, do you know a connector? So if you know a connector that's capable of it, we can totally make Mule. But I don't know how to start in the middle.
Yeah, me neither. That's why I'm asking.
Yeah. I think S3 you can start in the middle. You can, right? But I don't think FTP lets you start in the middle. Oh man, that would be nice, right? I think let's look at it. So multi-part.
But I mean, with binary, I think you could skip to a specific point in the stream or in the IO, right? And then start reading not from the start.
I could make my for each have a choice in it and an object store to know how many pages I've read and complete the process successfully. I just don't think I could do it without downloading byte 0 to my midpoint. I would have to download it and ignore it, which is
with FTP maybe. I think with HTTP you should be able to do it if you're downloading something.
Oh, there's a header with HTTP that says some kind of like watermark.
Yeah, for streaming, yes.
I think get object has part number and range, so you can accomplish that with S3 that way. But with HTTP, do you know what the header is? That's awesome.
No, I don't remember. But
request header. Partial. I'll just download. Maybe somebody will know. Range. There's a range header. So let's go find the range header.
I think if it's multi-part or if it's streaming, then you can say from which byte number to start reading, kind of.
Yeah, like this.
Yeah, something like this.
Dude, yes. That is cool. And that is new in Mule 4.10. We got the new HTTP connector that supports HTTP2. Now, I don't know if it needs to be HTTP2. Range might be supported on
No, it doesn't.
HTTP1.
I think it's prehistoric technology.
Oh, that's wonderful. Sometimes Mule doesn't support old stuff, but I think this time it does. Yeah. Yeah, I guess it's possible.
I'm seeing this a lot in EDI processing, so EDIFACT and all, right, where you just
EDI, because you mean as a normal operation or only as a exceptional case recovery?
well, also as normal, right? So when depending on which protocols have been used, but as part of the payload, it says like from which point of the payload to start reading the actual content. So it's kind of very old school way of describing payload.
Just give me the first 1,000, or give me 56,000 to 57,000.
Something like this, yeah.
Yeah. So I feel like this is kind of a little, dusty corner of the Mule world. We don't end up talking about big payloads that much, but I think it's when it becomes important, it's going to be super important for your project. So, well, that's what I brought today. And maybe maybe another study group, if people are interested, I can give more about connectors. And I think I did an intro to connector development last year, but we're trying to set up MuleSoft Forge to make it easier for everybody to just contribute new connectors, make enhancements to connectors. So I might be able to put one on. RJ's ears are perking up. I could put my name in the hat for an open source connector study group at some point, because I really want people to get more comfortable and make it a more common occurrence that we go build for and share code with each other.
Yeah, man, do that. Whitney's showing some interest in open source community, MuleSoft open source community. So yeah, that'd be great.
Yeah.
Good job showing how to handle more data. There was once a guy who is very famous who said that 640K ought to be enough. So
Mr.
here we
Gates.
are now,
Mr.
Yeah,
Gates.
exactly. I mean, here we are now, over 40 years later.
I wish that's what he was still most famous for.
Yeah, I know, right? 20 gig. Yeah, we'll leave it at that.
Yeah.
And, now you're talking about 20 gigabytes on one V core. So that's awesome, man. Great work. Thank you all very much for coming out. Ryan's already answered a lot of questions and taken care of a lot of questions and done a great job. We really appreciate everybody coming out. So I'm just going to go ahead and we'll roll on and stop the recording. And thank you for watching this, whoever's on the recording, and leave a comment. Thank you for coming out.
Yeah, thanks.
All right.
That was really great. Thanks, Ryan.
Yeah, you're welcome.